In this video, we're going to look at aqueous solutions and their properties. And we're going to begin with a discussion about water. And why do some things dissolve in water, like sugar and salt, and some things don't, like lead iodine? Well, that is because water itself is what's called a polar molecule. That is, the molecule overall is neutral. It doesn't have a formal charge. But that charge is not evenly distributed. And so I have two different models of water here. So every time you see this delta sign, that means that there's an uneven charge distribution. So we have delta negative. So this is saying that the oxygen has a negative charge, while the hydrogens have more of a positive charge. And let's look at a water molecule here, where the red area means negative, blue means a positive charge, and this green and yellow means neutral. You can see that overall the water molecule itself, although it's not formally charged, has an area of negative charge and an area of positive charge. And this matters a lot when we're talking about why things dissolve and why some things don't. So let's look at sodium chloride. If you remember from our previous videos, we said sodium chloride is an ionic compound. So there's no covalent bond. They interact purely by electrostatics. That is, a plus is attracted to a negative. And so when you put salt or sodium chloride in water, this water molecule is very polar. It has a negative end and a positive end. And so what will happen is that the positive sodiums will be attracted to the negative oxygen of water. The negative chlorines are attracted to the positive ends of hydrogen. And what we see is that the actual salt crystal starts to break up and it's surrounded by water molecules. And to us, it looks like it's disappearing when it's just dissolving. And we'll talk more about this in Gen Chem II, but dissolving is based strictly on intermolecular forces. That is, you measure the force between this sodium and this chloride, and you measure this force between the water and the chloride and the water and the sodium, and whatever generally is the strongest is what they interact with. But we don't need to be bogged down in that right now. Well, let's look at sugar and water. Sugar, here's a sugar molecule, has a lot of water and hydrogen. Sugar is not ionic. It's full of covalent bonds. So when sugar dissolved, it does not break apart like sodium chloride. And that's a big point. Ionic compounds break apart. Molecular compounds do not break apart in water. But what happens is that all these oxygens on sugar are negatively charged. These hydrogens are positively charged. So the water is attracted to these molecules, and it surrounds these molecules like it does the ionic compounds. And so when you put sugar in water, like the salt, it looks like it is dissolving. Now, when we dissolve sugar in water, or sugar and salt in water, we see interesting properties. One, salt makes electricity go through water. Sugar does not. Now, water itself does not conduct electricity. It's only the ions dissolved in water that makes it conduct electricity, and only certain ions make it conduct electricity. And so why is this? That's because, like I said, salt forms ions when it dissolves. These ions are what carries the electric charge through water. And substances that dissolve and conduct electricity, these things are known as electrolytes. So you might see like electrolyte enhanced water. Basically, that is just a fancy word for saying salt water. And if something dissolves in water and conducts electricity, we call that an electrolyte. While sugar is made out of covalent bonds. So when you dissolve sugar in water, it does not break apart. Therefore, it does not form ions. Therefore, it does not conduct electricity. And therefore, it is not an electrolyte. So for electrolytic solutions, we have different types of electrolytic solutions. We have strong electrolytes, And we'll talk more about this when we cover acids and bases later on in the course. But these strong electrolytes, they dissolve completely into ions. So sodium and chloride, you will not have any salt crystals left over. It'll all be separated sodium and chlorides. So this is a strong electrolyte. It makes a lot of electricity when you put a current through water. Acids can also be strong electrolytes if they're strong acids. Hydrochloric acid dissolves completely in water. It's a strong acid and a strong electrolyte. While weaker electrolytes do not break apart completely in ions, and a good example is vinegar or acetic acid. So here in this picture, we have some acetic acid molecules that have not broken apart, and some acetic molecules that have broken apart that have a hydrogen in there. So since only a fraction breaks apart, we call this a weak electrolyte because it's not going to conduct electricity as strongly as a strong electrolyte. As shown here, so we have sugar, not an electrolyte, does not make the light bulb go off. Acetic acid, weak electrolyte, you get some light, but when you have salt in water, you get a lot of light because it can conduct a lot of electricity. Now, not all compounds dissolve, so if something does dissolve in water, we say it's soluble, but if something does not dissolve, we say it's insoluble. And although things will still dissolve on a very small scale, we will generally say they're insoluble if they have a solid in water, such as silver chloride. Silver chloride does not dissolve in water, so it is insoluble. And we have solubility rules here where certain compounds will dissolve in water and certain compounds will not unless they're mixed with something else. Now, we're not going to go over the why of these rules, but I'm just going to present the rules here. And you are going to be expected to know these rules. So I would make flashcards of what's soluble, what's not soluble, and the exception to these rules and learn those. And so let's test your understanding of these rules. For each compound listed here, would you expect the resulting, that's supposed to be the resulting aqueous solution conduct electric current or not? So go back to the rules, try to figure this out, come back when you have an answer. Alright, let's take a look. So CsCl would conduct electrical current because 1, it's soluble, 2, it's an ionic compound. So when it breaks apart, it forms into a positive and a negative ion. While methanol is not an ionic compound. It's made out of only non-metal atoms, and so it is covalently bound, so it is not an electrolyte. CaNO2 is an ionic compound, so when it breaks apart, breaks into ions, does conduct electricity, while sugar, or not sugar, but C6 H12O6 does not break into ions because it's all non-metal atoms, and so they're all covalent bonds, so it does not conduct electric current. And that's it for this video, and I'll see you in the next one.